start by thanks for coming to ElixirConf 2021. It's great to see people in person. It's really cool that this conference center is where it began. The first two Elixir conferences were held here. So it's kind of a sense of nostalgia here that's kind of fun coming back. My name's Greg Vaughn, and I'll be talking to you today about fumbling with exceptions. I picked this topic in a way that made it easy on myself, because just in case I even fumble during this talk, you're still guaranteed to have an exceptional talk, right? Good crowd, okay. But yeah, I've set the bar and the level of humor. It doesn't get better than that, but. All right. Is the mic on? No. Am I not close enough? Maybe I should be close enough. Oh, there we go. Okay, I'll do that. This is how you can contact me online, various Elixir communities. I've been in Elixir community since the first Elixir conference, and I want to do a shout out to my new company, DScout. I started with them in March. They're sponsoring my trip here, and they're sponsoring the conference also. Well, we're all in on Elixir. We do qualitative research, which means like academic and market research, user experience, use our platform to connect to panelists in many different ways, including live interviews, media-rich sort of options for generating qualitative research, which we then consolidate. And we're growing, we're hiring, and if anyone is interested to talk about the company or our openings, please find me during the conference. I love meeting new folks. So, let's jump in. You've probably heard in the Elixir Erlang communities to let it crash. We don't handle errors, we let it crash. And the first time I heard that, my jaw dropped. It's like, that's not a resilient system. But the important thing to understand, it's not let the whole system crash. It's each independent little process can crash and not affect the whole, because we have supervisors. And that's really important in the large scale design of your system. Supervision trees should be probably 75, 80% of your error handling. But I want to focus in on some of the smaller parts here in this talk. Instead of the concurrent code, which is how the different processes communicate with one another, I'm going to focus in on the sequential code that's inside of one process. Because each process is one thing at a time, doesn't share memory, which is part of what I love about Elixir. So I'm going to be focusing on that section of the error handling. We're going to go over some of how Erlang uses errors and exits and their throw catch keywords, the data structures that they use. Elixir adds its own richer exception data structure on top of that. And Elixir also will even wrap those Erlang errors in many cases. Some of you who have been with Elixir for a while may have gotten some of those errors that got thrown up from the Erlang code that was just like nested tuples and lists and tuples of lists, and it was really hard to parse. And so Elixir has done a great job working on developer experience in how we can understand exceptions. So let's jump into code. I pulled this off of the GitHub repo for the Elixir standard library. And I've simplified things to fit on the slide, took out a lot of comments. But this is the core idea of what is in the exception.ex file. I encourage everyone to read the source code to the core libraries. Most of it is very readable, unless you're into some really complex parts. So the first thing it's doing is it defines a type, which is a data structure that's a map with some required underscore struct and exception fields and anything else you want to add to it. But at its core, it's a behavior. It defines 3 callback functions. 2 of them are required, and 1 of them is optional. The first callback is called exception, which I think of as the constructor. This is how you take some term and you output the exception data structure. Then you have the message, where it takes the exception data structure and spits out a string. It's kind of like the toString version. And then there's the optional blame, which we'll get to later. Since it's optional, it's not kind of required understanding. And then I put a little comment at the bottom here. There's another 1,500 lines in this file. Now, once upon a time, I would have wagged my finger and maybe judged somebody for having that long of a source code file. But with Elixir, I've learned to come to peace with that. It's not object-oriented. We don't have instance variables that are coupling various methods to one another. It's just a bunch of independent functions sharing a namespace. And so we can reason and understand about each piece of it in isolation. So the size of the files, I've learned to be okay with. It just becomes an issue of kind of navigating your editor, which is kind of an orthogonal concern. So moving on. Some more source code, this time from the kernel module, the def exception macro. It's not really that complicated, and again, I've simplified it. But what this does is it sets the module attribute behavior to this exception. So we are implementing the exception behavior. It's calling the def struct macro behind the scenes. So every exception is a struct, and it adds that required underscore exception field to it. So in a certain sense, an exception is that struct with this extra true field on it. And then the def exception macro will implement the message callback for you. If you have a field called message, it kind of gives that back to you. If you don't, it's up to you to do it. And it's overridable if it does implement it. And then also the exception itself. Another interesting little tangent. I know there's like just a few things the core team has decided that has to change or requires Elixir 2.0 to implement because it's a backwards incompatible change for semantic versioning reasons. They've identified a few of them, and I think they're waiting to bundle up enough of them before they really go through that hassle. But this is one of them. The default exception function deals with some backwards compatibility issues. But really moving forward, it says in the comments there that this kernel.struct bang is really what this should do in its default implementation. And so if you're writing code today, you should make sure that your exceptions are not exceptional in needing that backwards compatibility, but it will work with this moving forward. And of course, the def overridable is set on that. So you can change it yourself in any of your implementations. But you'll notice that this macro, in 90% of the cases, will get you the both required callbacks implemented. So that's really cool. So now, hopefully everyone's really clear on what exceptions are all about, right? Well, except, I don't know. I think I know what some of you are thinking right now. There's a question in your mind. Greg, you said they're a behavior, and then you said they're structs. You know, make up your mind. Well, the way I look at it is if I look at exceptions and squint a little and just tilt my head, they remind me a little bit of objects. Okay? Wait, rush. Don't rush for the doors. Hear me out. Objects have kind of gotten a bad rap. Really conceptually at the core, they're the idea of data and behavior kind of being bundled up together and kind of packaged together and used together. And even though some of us have had some bad experiences with that in the past, let's don't forget that it's a valuable abstraction and tool that we should keep around for potential use. I don't recommend that you orient your entire thinking about your software system around objects, but keep it in your programming tool belt because it's a valuable thing, and I think exceptions here are a great use of that concept. So I'll step off my soapbox now. Let's go into a little bit of IEX exploration. At a prior talk I gave, I got some really interesting feedback that surprised me. It wasn't about the topic of the talk, but about the way that I explored in IEX. It was something some people hadn't seen that comes naturally to me. So I want to do more of that and encourage people to explore. I like to think that IEX stands for I explore. You know, it makes it all about me. You guys have to figure out your own, acronym of what it stands for. And the idea of understanding one layer of abstraction below the level you're working helps you gain intuition about your system. Not because you can then couple to implementation details. Actually knowing them kind of helps you avoid that. It lets you know this data is available here, so this thing should be possible. And then you can look through the public APIs and figure out how to make it happen. Or if things go sideways and things aren't happening right, you have ideas of how to introspect and how to understand better. So that's something I encourage everyone to do. I have an IEX window open all the time. So let's start out. Oh yeah, the other thing I love about IEX, mixed formatter is not all up in my face. So I can play fast and loose with syntax. This is a production code, but this is, it saves you some keystrokes in IEX. You can define a module in one line. It's valid Elixir. If anyone wants to follow along, they're welcome to. But this is just defining a module that just simply calls the def exception. Real simple. But now I have this, and I can use some introspection functions. The compiler adds module info, for example, and you pass in attributes as the parameter. It shows you that these are kind of the persisted module attributes. We see that there's a version, which is kind of a hash of that's used by the Erlang code server for hot code loading, but that's a whole separate topic. But we see the behavior listed there too, that the def exception macro did add that behavior to our module, as we saw. We can verify that. We can also just go ahead and create one of these. Since we know they're structs, we can use our regular struct constructor syntax. But that looks like a plain old struct. It's also important in IEX to know that you can pass parameters to inspect and turn off that inspect protocol. So now we can see that this is really a raw map. And down in the Erlang layer and the Beam code, really all structs and therefore exceptions are really just maps. The fact that they have some special keys that mean special things to the Elixir layer is kind of not important down at the lower layers of the stack. And we see, again, that the exception field and the struct field are both added in. So let's move on a little bit more with IEX. It's a lot of code. The bold-faced pieces are the ones that are really important. It's different. I have 3 anonymous functions that raise exceptions in different ways. And it catches it and inspects it. In the first one, I'm just raising the raw struct. The second one, it's a 2-parameter call to the raise macro. And the third one, I'm calling the callback function on the module. So just digging into that a little bit more, raise is a macro defined in kernel. Again, if you were curious, in hex docs, there's a little kind of greater than, less than with a slash to the right side of all function and macro definitions. You click those, you go straight to the source code. It's a really great navigation tool that, if anyone doesn't know that. So raise, if it receives an exception, that's just a basic pass-through. It's got what it needs. It verifies it's an exception because of that double underscore field in the struct. Raise arity 2 takes the module name and a keyword list of field values. And that's going to call that exception function defined in the callback module. Now, the third time, I called that explicitly, which was unnecessary because that two arity version does the same thing. There's 2 other sort of convenience cases that the raise macro supports. Is you can pass just an atom to it, and it expects that to be a module that implements the exception behavior, and it calls the exception function with an empty keyword list. So you get just all the default values that you might define in there. It has another one that takes a string, and it uses that in the built-in runtime error exception, and it just sets that as the message. So those are 2 kind of convenience clauses in the raise macro. But all of them end up at a lower layer down at the erlang.error. And this is kind of where it all comes from. Down at this layer where we're dealing with tuples and atoms. And the docs for that, they take any term as the reason for the error. And in this case, we're giving them a map. And as far as they're concerned, it's a map, even though in Elixir, we consider it an exception struct. And it's only at this point when Erlang error is called that the stack trace gets generated. So you can generate these exception structs all you want to, and you're paying no penalty for creating stack traces or anything until it gets raised, or at least goes through the Erlang error. So let's look back into IEX a little bit more. I mentioned the blame optional callback earlier, and now we can revisit that. That takes 2 parameters, and it returns a 2-element tuple of those two parameters. So it's allowed to potentially update one or both of those. Now, this is a really stupid implementation that just to fit on a slide in IEX really doesn't do much, but you can do computationally intensive things to help the developer understand what happened in their situation. But what's going to happen here is when you raise the exception, which here I was lazy, I just used the module name, so I used that where it passed the empty keyword list. And so now we see that this prints out the message. So it went through the blame step. And this is used by IEX and XUnit in particular for when developers are interacting with the code. This is not production code. So you can do all sorts of computationally intensive things and not pay any production performance penalties. But you can make raving fans of the people who use your library because, hey, you really helped me out with these great error messages. I want to show one example from Elixir Standard Library. This is in the KeyError exception. And this is actually in that same exception file, that 1,500 lines that I left out earlier. They define all these exceptions in there. And I want to highlight, again, the bold-faced parts there, not all the code on the slide. Since KeyError implements blame optional callback, IEX and XUnit checks to see, is this available? Okay, let's call it before we do our final printout. And we see that under the right conditions, it will call this did you mean helper function. And that's going to call the string.jaro distance to try to find typographic errors, that you looked for this field name in some map or keyword list or struct. And can I say, did you mean one of these things that there's typographically similar to what you typed? It's just purely nice to have. It doesn't make your code better in production, but it makes the developer experience really great. And I really applaud Elixir core team for implementing this, and it makes Elixir a joy to work with. But you can take advantage of this in your own libraries and any sort of error handling that you do with your custom exceptions. So let's jump down a little bit into the lower level of Erlang errors. They have what they call 3 classes of errors. And the first 2, the throws and exits, came first. And then the error class of error, no, it's funny naming, but you gotta just deal with history here, came later. Throws is very, I don't know, primeval, I guess I might say. It's very much like a go-to or a long jump. You are throwing just a plain atom, and you are expecting some other code to catch that. It's mostly used in performance-critical situations where you're like in a deeply nested loop, and you suddenly need to kind of jump out, just ignore the stack and jump out this other code because, hey, we found what we're looking for and don't need to process the rest of this. You're probably not going to use it very often in your day-to-day coding, but know that it's there. The exits, these are kind of, hey, the process is dying. It can't handle what's going on, and this is what is referred to in the Erlang literature as their dying breath. And this is how links and monitors and the inter-process communication operates. They're dealing with the exits. And exit is a tuple with exit atom as the first element. An error is a little bit more kind of ambiguous because it's like something bad happened and maybe someone can catch it, but this is where stack traces actually get generated, is when it's in the error class of Erlang error. And this is represented in Erlang as a two-element, or not two-element, it's multiple elements, but it's a tuple with the error atom as the first entry. And you'll rarely probably need to dig down this deep, but I'm just kind of trying to go over things. In Erlang, they use the keywords try, catch, and after are what they support. And catch can pattern match on any of those tuples or bare atoms that I mentioned. You can still use catch in Elixir code, but you're dealing with the raw Erlang error data structure in that case. Sometimes that might be what you need to do, but I don't think that would be very often. Elixir further adds rescue and else. And rescue is where Elixir puts in their wrappers around the Erlang errors. It allows you to pattern match on struct names, and it will wrap corresponding Elixir errors in corresponding Erlang errors in the Elixir exceptions. So for example, if the Erlang code raises an argument exception, well, Elixir has an argument error, and it can wrap that and present it to you in a more familiar form. Else, I include here for completeness, it is a real sort of corner case when you're doing like tail call optimization, it's there, and it pattern matches the result of the try body when there is no exception raised. I really recommend, if you ever need to use it, look it up at the time, because I always have to refamiliarize myself with things like that. So now I want to talk a little bit more about different types of code you may be writing and the different ways you should be approaching error conditions. A lot of people use some of these terms interchangeably, and I'm going to try to define what I mean by them here and the way that I look at the errors differently. Libraries are passive code. They are sitting there waiting to be called. They're not starting processes. They're not active. And they should not make assumptions about what is truly exceptional. They really should be dealing with error tuples, at least primarily. They can offer bang variants for convenience. But for the most part, things that you may think in your library that, oh, a config file's missing, nothing can happen. Well, maybe some embedded logic knows that on the first boot up, it's not going to be there. It prompts you for it, creates it, and then restarts the supervision tree. So you shouldn't assume anything about what's exceptional to the application level when you're writing these passive libraries. And applications, I almost just kind of defined by, in that last step. They're the caller of those libraries. They're the ones that are managing the interaction with the end user of the application. And they're the ones that decide, hey, this is put an error in front of the user, a crash, or try to work around it. That's where that sort of logic should be handled. And then there's the frameworks, which are these weird sort of corner cases. I like to think of them as distinct from libraries by this Hollywood principle. I heard the chuckle. Don't call us, we'll call you, like a Hollywood agent. So the framework is going, we're managing the interaction with the user, but we give you hook points for your logic. A great example everyone's familiar with is Phoenix. Phoenix is a framework. Phoenix, with help of Cowboy and Ranch, are managing those processes that are the request-response cycle. And you plug in by writing your endpoint in your router and your controllers, and you're telling Phoenix, under these conditions, you call this business logic of mine. So in this case, it's more of a cooperative idea of what's truly exceptional. Phoenix has its own opinions about what is an error and what's not. It tries to convert certain things to status codes and present those nicely to the end user. But you can also plug in with your fallback handler and customize that yourself. So you're kind of playing together as a team. Because of this, frameworks are kind of the hardest code to really write well, in my opinion. So I would urge people, think about libraries first, and then maybe frameworks later. Talking more about writing libraries, I want to mention what I consider, kind of exceptional libraries, way to do them properly. And I'll mention this first idea. I first learned from Brooklyn Zelenka's, I hope I got your name right, her library early on in my Elixir career. And she's giving a keynote tomorrow afternoon. So much of the Elixir ecosystem uses an error and an atom reason. And I really like the idea of having an exception in there because it's an entire structure of data. It's richer data that you can provide more information to the application so they can reason more about how to handle these different error situations. When you do this, it's really straightforward to write bang versions because you do a case match and you can just raise the exception there. You're not paying for a stack trace penalty by creating the exception until you raise it. So it just gives the caller of your code more information to handle their errors more intelligently. And when you use the tuple, the unbang functions, I called them, the callers can do these case or with else expressions, and they can just catch error exception. And they can treat any exception the same if they want to, or they could pattern match on the different struct types of the exceptions, or you could include a reason field in your exception, and they can use that to further subdivide how they want to handle different situations. So now I'm down to the point. This is the whole reason I kind of got me into giving this talk. And at my prior job, I used this as a refactoring technique. And I want to share this, and I'd love to hear some feedback if other people have used it, or if in the future you do use it and like it. But to give you a little bit of background, at the very kind of simplified level, we were doing order processing as a service. So our customers were hiring us to handle their orders. And they had third-party inventory systems that we were integrating with on their behalf. And there were multiple of those supported. And there were third-party public-facing marketplaces that were also supported. And they would give us API tokens on their behalf, and we would handle these orders. And there were lots of distributed systems, issues, timeouts could happen. Each one of these had their own little idiosyncrasies. And so we had multiple steps involved in our order processing. At the high level, it was a big with expression that had 6 or 7 steps. And then maybe a dozen sort of else clauses for all the things that could go wrong. But then if you dig in, some of those main steps in another function, maybe in another module in some cases, was another 4 or 5 step with expression with its own half dozen error clause or else clauses. And it was grown organically, and it was getting kind of to the point where there were corner cases, and we were having trouble diagnosing what went wrong in some cases. And when money's changing hands, our customers are going, what went wrong, and when are you going to fix it so it doesn't happen again? So we really couldn't just let it crash. And so we were trying to handle those errors pretty carefully. So what I came to when I understood exceptions really are structs, they're rich data structures, they're modules we can add our own logic to, I created what I call the order fumble. Now, I don't expect everybody to be a sports fan, but the idea of a fumble is you lose possession of the ball, and the other team might catch it, and so sad for you, or you might be able to recover it, and maybe even advance your position. So that's why I called it a fumble instead of an exception, even though it is an exception. I used a couple of things. Knowing that it's going to use def struct, I could use the enforced keys, which is something that the def struct will use, so I can make sure that we're always creating it properly in our code. I found the exception callback name a little bit kind of long, and I like calling it new. It seems like a constructor. And I did a little pattern match here so that what we have in our context field is always this particular type of struct, which was our context of the order. It included like customer IDs. It included which of these third-party services they were using, like the raw JSON responses from those, and even our database record. So we had a lot of context of what was going on when we were processing an order when something went wrong. And we needed this order context to consolidate our logic here. I also mentioned we have a step in there, so we actually named the step of those high-level ones I mentioned because we might want to react to the same error in different steps, different ways. And since I didn't have a message field in there, I had to implement that myself. Pretty simple. It shows us our reason and our step. And so this is like the rest of it. This is kind of really the big payoff here. That I had this mitigate function, is what I decided to call it. And this uses these module attributes that give us different categories of how we want to handle problems before the process crashes. We need to be able to store state in the database, the status of the order. In some cases, we have ones that are called manual. So again, very simplified example, and there were a lot more of these in real life. This just to fit on the slide and get the idea across. If we're in the inventory step and we get mismatch counts, right? That's something that we as programmers, we can't fix. Something's wrong somewhere, someone's trying to buy too much of, more than what you said you had, and we have to notify our customers. And so we can go through a case statement in there and have a helper function handle notification. And that can look up, hey, this customer likes email or likes push notification or texting or whatever, and can handle all of that. So we're contacting our customer as quickly as possible, notifying. And other ones, retryable. If we got a timeout while we're talking to a payment processor, let's wait a few seconds, try again before we, exhaust retries, and then it becomes a manual notification. And then finally, if we don't know, we didn't expect any of this step or error to happen, we raise. And so our exception handling service, we were using AppSignal. So that's going to notify us and be loud in our face, and we're going, we missed a case in our code and made it clear to us that that needs to be fixed. So this was the core idea, that the module is a target for refactoring. We were able to handle and consolidate how we're handling these error conditions into one place. And it was able to simplify a lot of our logic. And that was the core sort of design idea that I wanted to get across here. And that is hopefully not too anticlimactic. So the main takeaways. If you can handle the truth, exceptions are objects. If you can't, they're behaviors and structs, okay? It's this quantum superposition, okay? Use blame in your own libraries, and you'll have raving fans of the developers that use your libraries. I really consider strongly, I'd love to see our ecosystem returning error and exception a lot more than just the atom reason. And you can have one exception for your whole library with different reason fields inside of it, or you could have separate exception structs, which is whatever works best for your situation. And that exception module, they're modules. They're a refactoring target. They're a way to put common behavior dealing with this sort of my order fumble. Something went wrong with the order, and let's try to recover before we die. So thanks for coming. This is how you can contact me. And we're hiring, and happy to talk with anybody. Love meeting you folks. And thanks for coming. Do we have any questions? Do we have anyone who's brokering questions, or this is up to me? Okay.
Simple question. Exceptions and errors are the same thing during all this talk?
Okay, the question was exceptions and errors, are they the same thing for the purposes of this talk? Errors are situations that you don't want to happen. Exceptions are complicated. When you raise them, they become something different. They are blowing the stack trace. They're ready to kill processes and get supervision trees involved. So raising an exception is one way of responding to an error. But errors are also the terminology used down in the Erlang layer, and exceptions are the terminology used in the Elixir layer. So it's complicated. And you can create the exception struct without raising it. So there's ambiguity there, and I'm sorry I didn't clarify that. Okay. Here.
So earlier in this, several slides ago, you had kind of a quick summation of like try, rescue, these sorts of things. There was an after keyword, and do you want to talk about that at all? Or?
That's another sort of performance optimization thing. If you are in a try block, the lower levels in the beam have to store that stack frame. They can't just use tail call optimization because an exception may come and they need to remember that position in the code. When you use an after, it's kind of, in the code in there, you know you're safe to reuse the stack frames. So it's a very kind of low-level technical thing that probably you'll rarely interact with, but that's what that's for.
Thank you.
Anyone? We're here?
When you're talking about your
So the question was the order fumble shared for the whole workflow, or were there other kind of sub-fumbles for different steps in it? You could certainly design it that way, and I chose to use that step field in the order fumble so that they're not separate, and it was more of a consolidating effort, and that worked for our case.
And what was the step, like what would you put inside the step? Would you put
Okay.
the name or?
Well, what I showed a little example there. Here, the keyword list under manual, like inventory was the step name, or payment was the step name. In some cases, we could put things on hold. So hold was a step name, or fulfillment were kind of the various high-level steps of our order processing flow.
And then, sorry, last thing is, how did y'all go about those specific names? Is that based off of just like the module names, or like how would you decide this is a payment?
Well, it was based upon the business logic. Needs those steps to handle an order, and we didn't spend a lot of time thinking about the naming of it. These just kind of came out. We just had casually talked about, well, during the fulfillment part of this order, it failed, or while we were checking inventory. I'm sorry?
Just
Known terms to the team, to the business domain. Yes. Over here?
Are there any resources in computer science land that do like a deep dive on like error handling and like language agnostic? Like these are the things you can look into when you really want to understand errors, exceptions, all of this. And you can take typical language like any you run into.
Okay. So the question is looking for like background research, computer science, language agnostic, error handling advice. And I can tell you confidently that, yes, there have been people writing about that. I don't have anything in particular I can recommend specifically, but I know that has been an area of lots of research in computer science. I've picked up pieces here and there, but I don't have anything fresh that I could try to recommend off the top of my head. Sorry. Over here?
I like that error tuple exception thing. I was wondering if you knew of any packages or examples of that in use to kind of look at.
I'm trying to remember.
I've not seen a whole lot of it.
I have not seen a lot of it. There have been some blogs that Michał, I'm probably messing his name, Muscala, has used that. I've seen Andrea Leopardi also talk in and add on that. So there's quite some people thinking about it, but as far as a major package, I don't have one off the top of my head. Question over here.
I noticed like the string from IO data, and it just made me think of Erlang, and was wondering if you had any kind of like common themes or patterns you see from dealing with Erlang exceptions, like things to watch out for when you're getting stuff back from Erlang libraries or using Elixir.
Because you're looking for advice for handling the Erlang errors and wrapping them yourself?
I would say whatever the question that would be like any common themes when dealing with Erlang from Elixir.
The most common theme I have is the Elixir core team has done a great job. I haven't seen an Erlang error in quite some time because they've done this wrapping and put this around it. I don't spend a lot of time calling the Erlang libraries directly. There's something we should all keep in mind, but I don't have any particular advice on that area. Sorry. Now, one more question, or let me let him go since you asked one already.
So the distinction between the bank version of a function and the non-bank version of a function, is that the pattern universally followed in libraries, or?
Well, considering open source is what anybody wants to write in their spare time, nothing's universal. But the idea of returning an OK and a value, or an error and some reason, is actually well used in the Elixir community. And it's not too far to go from a reason atom to a reason exception. And that's kind of the advocacy that I'm speaking of here, to give richer data to the callers. And we are just about, we're out of time, and I'm gonna call it with no proctor in the room. So thanks for coming. We should talk later if you have other question.